Welcome to Science Manthan. So, have you ever wondered why a swimming pool feels absolutely freezing when you first jump in, but then perfectly warm just 5 minutes later? Today, we are diving into how we accurately figure out whether something is actually hot or cold. You interact with temperature every single day, right? But the science and the history behind how we capture that measurement is honestly fascinating. Let's get started.
Okay, let's kick things off by imagining a quick, fun experiment you could do right now in your kitchen. Picture three bowls sitting right in front of you. One is filled with warm water, one with just room temperature tap water, and the third with ice cold water. Imagine sticking your left hand in the warm water and your right hand in the ice water. Just leave them there for a second. Really feel that intense contrast. Now imagine pulling both hands out and plunging them straight into that middle bowl, the one with the regular tap water. Your brain gets completely confused. The hand that was in the warm water is suddenly screaming, "Whoa, this is cool," while the other hand is actively telling you, "No way, it's warm." This simple test is just wild because it perfectly proves that our sense of touch is highly subjective and easily fooled. Basically, touch alone absolutely cannot reliably tell us if an object is truly hot or cold. And well, because our biology plays these tricks on us so easily, science has to step in with a rock-solid concept, and that is temperature. Temperature gives us a completely reliable measurement of how hot or cold a body is. It is a foolproof system where a higher value guarantees a hotter body and a lower value means a colder body. There is literally no guesswork or subjective feeling involved here. So to actually capture this measurement reliably, we use a tool called a thermometer. But scientists split these into two main categories depending on what needs to be done. First up, we've got the clinical thermometer, explicitly designed for measuring human body temperature. Second, you have the laboratory thermometer for scientific experiments. And it's a really good thing they're separated, honestly, because you definitely wouldn't want to use a giant, rigid laboratory thermometer to check your kid for a fever. Now, it wasn't that long ago that dropping a thermometer was a literal household emergency. The older models relied on mercury, which is a highly toxic element. That meant a simple broken glass tube created a pretty serious safety and disposal hazard. Thankfully, today, battery-operated digital thermometers have largely taken over. They offer incredibly safe handling, they use these highly accurate heat-sensitive sensors, and they give you a clear numerical display that makes checking for a fever completely stress-free. Beyond those traditional devices, we also have non-contact or infrared thermometers. You probably remember these becoming a super familiar tool globally during the COVID-19 pandemic to safely screen for fevers. Because they check body temperature from a distance without requiring any physical contact whatsoever, they drastically reduce the risk of cross-contamination. It really is an absolute game changer for public health. Section 1. Measuring your body temperature. Let's get right into it. Taking a proper reading is all about precision, you know? First, you start by washing your hands and cleaning the tip with soap and water. Then reset the device and place it snugly under your tongue. Now, here's why that actually matters. Keeping your mouth completely closed stops cooler outside air from messing up the reading, and putting it specifically under the tongue gets the sensor much closer to your core blood vessels. Once you hear that familiar beep, you just read the number, record it, and finish up by cleaning and drying the tip for next time. It all centers around one magic number, and that is 37.0 degrees Celsius. This is the commonly accepted average normal body temperature for a healthy human. It basically acts as the ultimate baseline that doctors and medical professionals use around the entire world. But hey, don't panic if your reading isn't exactly 37.0. Remember, it's just an average. It naturally fluctuates. For instance, if you take your temperature right after an intense gym session or late in the evening, it's naturally going to read a bit higher. A perfectly healthy person is going to see these tiny shifts based on their age, the time of day, or just how active they've been recently. Generally speaking, human body temperature won't fall below 35 or rise above 42 degrees Celsius. That is our normal operational range. But keep in mind, if you measure under the armpit, which is a really common and safer practice for small kids or older folks, the reading is generally going to be half a degree to 1 full degree lower. Why? Well, because you are measuring an external skin surface rather than an internal core temperature, so it's naturally just a tiny bit cooler. Section 2. Understanding temperature scales. Let's look at the math. Think of these scales kind of like translation apps for different scientific languages. We've got three main ones: Celsius, Fahrenheit, and Kelvin. While Celsius is our daily standard for clinical and weather measurements, and Fahrenheit still pops up in certain regions, Kelvin is the official SI unit. It is the absolute gold standard language that researchers rely on in the laboratory. Depending on what part of the world you're watching this explainer from, you might be totally used to hearing 98.6 instead of 37. That average normal body temperature of 37.0 degrees Celsius is exactly equivalent to 98.6 degrees Fahrenheit. But while Fahrenheit is still widely used in everyday conversation in places like the United States, it is rarely used in modern global scientific studies today. Now, if you ever need to jump into scientific research, you've got to convert to Kelvin. It sounds a little complex, but the math is actually beautifully simple. You just take your Celsius reading and add 273.15. This means a comfortable room temperature of 25 degrees Celsius instantly becomes 298.15 Kelvin. It's a strict mathematical shift that guarantees absolute consistency across the globe. When writing these down, scientists follow some incredibly strict rules. Imagine a tiny formatting mistake in a science journal throwing off a multi-million-dollar global experiment. To avoid that, you always capitalize the scale names, like Celsius, Fahrenheit, or Kelvin, but you keep the unit names, like degree or Kelvin, entirely lowercase. You also leave a space between the number and the symbol, and crucially, you never, ever use a degree symbol with Kelvin, just the K. All of this incredible modern precision actually leads us to a pretty fascinating historical question. If our hands are totally unreliable and thermometers are a modern invention, how on earth did ancient healers manage to detect a fever?
Historically, even in ancient India, healers would check a patient's pulse rate. They observed that an elevated temperature often forced the heart to beat much faster. But because a lot of non-fever conditions, like stress, exertion, or other illnesses also alter your pulse, it just wasn't foolproof. And so we return to the core truth of our explainer today. Precise temperature measurement with a proper thermometer is literally the only reliable method we have to cut through our body's illusions.
It really makes you wonder, doesn't it? Hundreds of years from now, will our current digital thermometers look just as primitive to future scientists? Well, like, subscribe, and share for such more science-related videos. Drop your comments and queries in the comments section, and we will catch you in next one.